All right, in this lesson, we're going to talk about atomic structure, and what that means is it's the building blocks or the bricks that make up an atom. And when you look at an atom, there are three important parts to the atom, and you've heard of all of these. In chemistry, we're really going to talk about them in detail. And the first one we talked about in the last video is right here, and it's called the electron. And it's assigned a charge of -1. It is the negative part of an atom. So if you come into class and you have kind of a grouchy attitude, I might say, stop being such an electron. A proton is the positive part of the atom, and it has a charge of exactly +1. The fact that these are ones is important because that means that if you have equal numbers of protons and electrons, which all atoms do, then the atom is neutral. Because if you have 20 minuses and 20 pluses, they cancel out. You can imagine if you had an atom like here, and then there were, let's say, 3 pluses, which would be protons, and 3 minuses, they all would cancel. You'd end up with these canceling here, these canceling here, these canceling here, and there'd be no net charge. And that's true of all atoms. There is no net charge. And the last particle is called the neutron. Here's the neutron, and it has no charge. And it was discovered about 20 years after the proton and the electron were discovered. Because of the fact that it has no charge meant it escaped detection. Magnets didn't affect it. Other charged particles didn't affect it. So it was very difficult to discover. Notice this relative mass. What this means is that if you arbitrarily, if they just say an electron has a mass of 1, and there is no unit on this, it's just saying that a proton is 1,836 times bigger in terms of mass than an electron. And a neutron is about the same mass as a proton. But they are both much bigger than an electron. These two are huge compared to the teeny little electron. So this guy is very small. And that's in terms of mass. If you were to look at an atom, the nucleus would be a tiny dot in the center of the atom. And let's go blue here. This would be the nucleus. And again, that has the protons and neutrons. The rest of the atom, all this area, would be where the electrons are. And now they're very small compared to the proton and neutron. So why this big area? Well, it's because they're very small, but they're also very fast. And so they can be anywhere in this area. You can imagine if you had a pet cheetah, and the cheetah had little cheetah babies, and then there were a bunch of little cheetahs. They're very fast. You would need to have a huge area for them to spend their time. And it's the same with the electron. In fact, the rest of the atom here outside the nucleus, where the electrons spend their time, is called the electron cloud. Because they're so fast, they blur. If you were to look at them, it would look very blurry. They'd be everywhere all at once, almost. Kind of like when you look at a fan in the summer. You've got the fan going in your room. If you look at the blades, you can't tell where the blade is at any one time. It just kind of all blurs together into one blade. And that's what the electron cloud is like. One way to remember that the neutron has no charge is a joke I like to tell. A neutron went into a bar, and the bartender said, "What do you want?" And the neutron ordered the food. When the food came, the neutron went to pay for it, and the bartender said, "For you, neutron, no charge."